Hi, this is Ramachandran from onlinemathforall.com. This video is about problems on limits and continuity part 1. Here we have a question in which we have a piecewise function, that is f of x is equal to 1 over 2 negative x for 0 less than x less than 1 over 2, 3 over 2 negative x if 1 over 2 less than x less than 1, 1 over 2 if x is equal to 1 over 2. So the target of the question is the function continuous at x is equal to 1 over 2. So a piecewise function is given. We have to check whether the piecewise function f of x is continuous at x is equal to 1 over 2. Okay, I'll just tell you the way in which the given problem to be solved and get the answer. Whenever we have piecewise function and we want to check whether the piecewise function is continuous at some particular value of x, what we have to do is we have to find left hand limit and right hand limit for the given value of x. If the left hand limit and right hand limit are equal, we can say that the given function is continuous at the particular value of x. In our problem, x is equal to 1 over 2. For that we have to check whether the function is continuous. So we have to find left hand limit for x is equal to 1 over 2, and also we have to find right hand limit for the same x is equal to 1 over 2. If the left hand limit and right hand limit for x is equal to 1 over 2 are equal, we can say the given function, the given piecewise function f of x is continuous at x is equal to 1 over 2. Okay, now I'll show you how to find left hand limit and also right hand limit for x is equal to 1 over 2. So first let me find left hand limit, that is so left hand limit is equal to limit x tends to 1 over 2. So there is a negative at the top of 1 over 2, because this negative indicates we take left hand limit of 1 over 2. Limit x tends to 1 over 2 negative f of x. Here we have three parts for f of x. That is, the first part is 1 over 2 negative x, second part is 3 over 2 negative x, the third part is 1 over 2. So here, which part to be considered for f of x here? The students may have a doubt here, that is what I said now. So which part to be considered for f of x here? It's very simple, because we take the left hand limit, 1 second, on the real number line. If we say that we take left hand limit for 1 over 2, it says the values on the left side of 1 over 2 to be considered for x. Students, please listen to me carefully. Since we are trying to find left hand limit for x is equal to 1 over 2, we have to consider the values on the left side of 1 over 2 for x. So the values on the left side of 1 over 2 on the real number line are less than 1 over 2. So here the value of x to be less than 1 over 2, because we find left hand limit. So here we have three intervals, 0 less than x less than 1 over 2, 1 over 2 less than x less than 1, x is equal to 1 over 2. In these three intervals, we just have to see where x is less than 1 over 2. So in the first interval, the value of x is less than 1 over 2. Since we are finding left hand limit, x has to be less than 1 over 2. So the part of the function where x is less than 1 over 2 to be considered for f of x here. So the part of the function, that is the first part, 1 over 2 negative x, is for the interval 0 less than x less than 1 over 2, where x is less than 1 over 2. So that part can be considered for f of x here. So I hope the students can understand what I am trying to say. So here the students may have a doubt. We have three parts for f of x. So which part to be considered for f of x here? It's very simple. Since we are trying to find left hand limit of x is equal to 1 over 2, so we just have to consider the part of f of x where x is less than 1 over 2. So the part of f of x, 1 over 2 negative x. So for this particular part of f of x where x is less than 1 over 2, so we can consider this particular part for f of x in this left hand limit. So limit x tends to 1 over 2. So here instead of f of x, I am just going to take 1 over 2 negative x, the first part of f of x. So because for this part x is less than 1 over 2. So that is the reason I am taking 1 over 2 negative x, the first part of f of x. So now the next step what I have to do is I just have to apply the limit 1 over 2. So where I find x, I'll do this step on the next page. So we get 1 over 2 negative, instead of x I just apply the limit 1 over 2. So we get 0, that is 1 second. So we get the left hand limit 0. In the same way I have to find the right hand limit. So right hand limit is equal to limit extends to 1 over 2 positive. So this positive indicates we consider the right hand limit of x is equal to 1 over 2 f of x. So again the students may have a question. So we have three parts for f of x. Which part to be considered for this particular f of x? It's very simple. Since we are finding right hand limit of x is equal to 1 over 2, we have to consider part of f of x where x is greater than 1 over 2. I mean the value of x is greater than 1 over 2. So I'll go back to the previous page because there we have problem. Please give me a moment. Okay, so here we have to find the part of f of x where x is greater than 1 over 2. So it's very clear here x is greater than 1 over 2. So we can consider the part f of x equal to 3 over 2 negative x. So this part can be considered because for this part only x is greater than 1 over 2. Since we are finding right hand limit of x equal to 1 over 2, x has to be greater than 1 over 2. So for this we have the part of f of x is 3 over 2 negative x. Please give me a moment. Okay, so now I am going to take 3 over 2. 1 second, limit extends to 1 over 2 positive. 3 over 2 negative x. This is a part I took for f of x here because this is a part we have for f of x for x greater than 1 over 2, because we are trying to find right hand limit of x is equal to 1 over 2. Right hand limit is nothing but the value of x on the right side of 1 over 2. So the values on the right side of 1 over 2 is nothing but greater than 1 over 2. So now in the next step what I am going to do is I am just going to apply this limit x is equal to 1 over 2 in the given problem here. So 3 over 2 negative 1 over 2. I'll just proceed the next step on the next page. So 3 negative 1 over 2. 3 over 2 negative 1 over 2 or something but 3 negative 1 over 2. So it will be 2 over 2. So finally we are getting 1, that is right hand limit. So already we have found the value of left hand limit, that is 0. The value of right hand limit is 1. So left hand limit is not equal to right hand limit. So these two limits are not equal. Left hand limit of 1 over 2 x is equal to 1 over 2, right hand limit of x is equal to 1 over 2, both are not equal. Since the left hand limit of x is equal to 1 over 2, right hand limit of x is equal to 1 over 2 are not equal, so we decide the function f of x is discontinuous at x is equal to 1 over 2. That means the function is not continuous at x is equal to 1 over 2. So the reason is left hand limit and right hand limit are not equal. So in this kind of piecewise function, to check whether the function is continuous at the particular value of x, we just have to take left hand limit and right hand limit. So when we are take left hand limit of the given value, we may have a question. So because we have three paths for f of x, which part to be considered? It's very simple. So if you take left hand limit of a particular value, say x is equal to 1 over 2, so we have to find the we have to take the part of f of x where x is less than 1 over 2. So in that part of f of x, we just have to apply the limit x is equal to 1 over 2. So we have to, in this way we can get value for left hand limit. When we are trying to get right hand limit for x is equal to 1 over 2, so we just have to get the part of f of x where x is greater than 1 over 2. Because the right hand limit means we just have to consider the values of x on the right side of 1 over 2. So on the right side of 1 over 2 means the value of x will be greater than 1 over 2. So in this way we have to get part of f of x for right hand limit. In that we have to apply the limit 1 over 2 for x. In this way we can get the value of right hand limit. After having received both left hand limit and right hand limit, we have to check whether the left hand limit and right hand limit are equal. If they are equal, we can say the function is continuous at that particular value of x. In case they are not equal, like in our problem, because in our problem left hand limit and right hand limit are not equal, so the function f of x is discontinuous at x is equal to 1 over 2. I hope the students would be able to understand how to do this kind of questions in exams. Okay students, please visit www.onlinemathforall.com for more videos. Thank you.